In this video, we'll be looking at polynomials. Polynomials are a type of function, and here, the easiest way is just to look at some examples. However, the definition is here. So an expression of terms in which the terms have non-negative integer powers of the terms example x only. So it's a bit wordy, but what it's trying to say is that you have an expression of terms, so let's say like x squared plus 3x minus 4. So each of these are the terms, and then which have non-negative integer powers. So the first part is a non-negative. So that means that these values here have to be non-negative, and they have to be integer values. So by integer, they can't be decimals. They have to be like 1, 2, 3. Another way of thinking about it is whole numbers. And that's referring to the powers. So x squared plus 3x to the 1 minus 4. Now, normally you can just write in a function and a polynomial like this, x squared plus 3x minus 4. But it's important to also think about like x squared plus 3x1. So these are x to the power of 1 there, but x to the power of 1 is just equal to x. So they're the same thing. And then minus 4x to the 0. Now, any number to the power of 0 always equals 1. So that's why you can just put x to the 0 in there. And now 0 is a non-negative integer power, so a polynomial can contain constants. So positive or negative constants, as it's not about if the terms are positive or negative, but rather if the powers. So important to look at if the powers here are the ones that you have to look at. So here's an example, a few functions. You have to work out which one of these are polynomials. So you have x to the power of 5 plus x to the 3 minus 4x4 plus 2x. So have a look at those and try and identify which ones do you think are polynomials. So firstly, a. So a is a polynomial. So a is a polynomial. And that's because you have x to the 5, so 5 is positive and it's an integer, plus x to the 3, 3 is a positive integer, minus 4x, as I said, minus is fine, as we're looking at the powers, 4, that's fine, 2, that's fine, and then 3, that's fine, because if you remember, that's x to the 0. So that is a polynomial, and they don't have to be in the order. Up there you have the highest power to the lowest. However, a polynomial can be in any order, as you can just rearrange the terms and it'll be the exact same function and the exact same polynomial. Yeah, so what about b? So we'll look at b now. We have 2, so that's fine. So 2 is an integer and it's positive. And then 4, it doesn't matter what it is there. Plus 2x, so that's fine again. Plus x to the negative 1, and so that's when it's not a polynomial. Plus 3, that's fine. So going back to this, so plus x to the negative 1. Well, this isn't a polynomial because negative 1 is not positive. As you can see, it is a negative number. So therefore, this is not a polynomial. And just quickly, if you remember, x to negative 1 is equal to 1 over x. And that continues, x to negative 2 is equal to 1 over x squared. So if you had an equation 4x squared plus 2x plus 1 over x, or 1 over any type of x, then you know it's not going to be a polynomial. Okay. So that one is not. So looking at C, we have x to the 3 on 2 plus x plus 2. So beginning with the right hand side, so plus 2, that's fine. Plus x, that's fine. x0. Plus x 3 on 2. Now that is not a polynomial, and that's because 3 on 2 is equal to 1.5. Now even though 3 is an integer, 2 is an integer, 3 on 2 is not an integer, not a whole number, so therefore not a polynomial. Solving polynomials are the exact same as solving a function, as they are functions, so you can treat them the same. So if we have px is equal to 2x squared plus 3x plus b, this is a polynomial, assuming that b is just a real number. So b is equal to a real number. So that's like saying that b is a constant. So we can think about that as b to the x0. So that is a polynomial. It's 2, 1, 0, all positive integer values. This can be treated as fx is equal to 2x squared plus 3x plus b. So that's the exact same thing, but we're just calling it px, and that's a normal, quite common notation for polynomials as p for a polynomial. So the p2 is equal to 10. So what does this tell us? This is saying that when x is equal to 2, px is equal to 10. And that notation is there. So that's like saying that px is equal to 2 is equal to 10, so p2 is equal to 10. Now that we have an equals to 10, we now have an equation. So this was just before was a polynomial, and now we've learning it equals something, so it's equaling 10. We now have an equation which we can solve for, and therefore find the value of b. So subbing x equals 2 and then making the right hand side equal to 10, we will get 2 squared plus 3 2 plus b is equal to 10. So you can see that equals to 10 refers to there, and I've just subbed x equals 2. So 2 squared is 4, 4 times 2 is 8, plus 6 plus b is equal to 10. 14 plus b is equal to 10. Therefore, b is equal to negative 4. So we've solved that, and then they may say, what's the equation of the polynomial? Therefore, the equation, or you can just say px is equal to 2x squared plus 3x minus 4. So what happens if you have two unknowns? So here we have a, and here we have b. So a and b are both constants. Now we've given two conditions, so because we've given two, we can now solve for two by getting two simultaneous equations and then solving them. So it's the same process as before, but now we have to sub in both points. So we'll firstly sub in this point here. So p1 is equal to 5. We get 2, 1 to the power 3 plus a to the 1 squared minus 3, 1 plus b is equal to 5. Solving that, we get 2 minus 3 is negative 1. So negative 1 plus a plus b is equal to 5. Therefore, a plus b is equal to 6. So at first we don't know how to solve that. However, we've got an equation just in terms of a and b. Now we can look at p2 is equal to negative 2. We get 2 to the 3 plus a 2 squared minus 3 2 plus b is equal to negative 2. And that gives us 8, 16. So 16 minus 6 plus 4a plus b is equal to negative 2. So 4a plus b is equal to negative 12. So we've got these two equations here. We've got 1 and 2. So we can solve these. So rearranging 1, we get b is equal to 6 minus a. Subbing that in, we get 4a plus 6 minus a is equal to negative 12. 3a is equal to negative 18. A is equal to negative 6. Now, summing that into there, we find that because a is equal to negative 6, so a is equal to negative 6, subbing into 1, we find that b is equal to 12. Therefore, if we had to write the polynomial, I'm just running out of space, we can write it as, therefore, px is equal to 2x to the 3 minus 6x squared minus 3x plus 12. So we've just solved the equation, and we've worked out what the polynomial is for two constants if we're given two conditions.